Good evening. Can you hear me?
Yes, sir.
Yes, sir.
Yes, sir. Good evening, sir.
Good evening. We will start just within 2 minutes. Just wait for a few minutes. So once again, I welcome all of you for this session on machine learning. Since we are starting after a break of week, or we are having a session after 15 days, so I will be revising our previous content so that everyone should be on the same page. And today's session is very interesting because we are going to complete all the classifiers in this session. You know that we have a concept of classification where we can predict a particular uh, categorical values, one out of two or one out of multiple scenarios. If we predict one out of two, we called it as binary classification. But if we have multiple classes, then we call this particular situation as multi-class classification. You are familiar with our earlier discussion, and we have so far discussed logistic regression and k nearest neighbor as one of the technique for classification. And we were discussing by considering a database for purchasing a Alexa product on basis of few attributes. So I will be revising everything again, and particularly two classifiers. And we will be covering in this session. First of all, we will discuss, or we will cover logistic regression, then k nearest neighbor, then we will discuss decision tree, random forest. Of course, we will be also discussing support vector machine for linear and non-linear data. And in the end, I will try to touch the idea of naive base also. So ultimately, this will make a very concrete session where we will be implementing all the classifiers maybe in just 60 to 70 minutes. So let's start with our discussion. So let's first of all start with the concept of logistic regression. You are already familiar with this concept. We will be quickly revising this concept. So, yeah. So logistic regression is a actually a regression, but we are tweaking the concept of regression so that we can apply it for binary classification. And in case of regression, we have simple and multiple linear regression. This is the equation of simple linear regression where we are predicting y on the basis of one input attribute. We can also predict y on the basis of multiple input attribute. Then this case is called as multiple linear regression. The common example of regression is predicting the salary on the basis of experience. And in this case, we try to fit a straight line so that we can predict the salary for a given value of experience. But uh, we can also apply regression, or we can also apply, or we can also tweak this concept to apply it over a classification. And here you can see that we have a binary classification in the form of 0 and 1, and we want to apply uh, regression over this. So if we try to fit this straight line over this, there will be a lot of errors. All these data points which are away from this predicted line will be considered as error. And we can manipulate this concept by considering this as a probability line, because ultimately you know that in regression we are predicting a particular value. So here I am predicting a value, and that value may be between 0 to 1. So if, let's suppose, I am predicting a value 0.2, I can map these values to 0. But if I am predicting a value 0.9, I can map this value to 1. So I discussed in our previous session that we can keep a threshold value 0.5. So if predicted value is between 0 to 0.5, we will map all these values to 0. And if predicted value is between 0.5 to 1, we will be saying that the output is 1. So ultimately, we can create a binary classification for this. But for this, the only region which is of our interest is between 0 to 1. But we have some issues in this. You can see that here the values is also going in the negative, and here value is also going above 1. So we have to solve these issues, because probability should be between 0 and 1, but here we also have a negative value and a value which is shooting above 1. So to remove these points, we apply sigmoid function, and the advantage of sigmoid function is that it has a value between only 0 to 1. So all the values below 0 will be considered as 0, and all the values above 1 will also be considered as 1. And sigmoid function also apply when we apply sigmoid function over this, it will also smooth our curve. And this smoothing of curve is actually further helpful to improve the accuracy of our system. So ultimately, what we obtain that we have a predicted values, and we can map this with a case of probability. So if our value is less than 0.5, we will be saying it is 0. And if value is more than 0.5, we will be predicting it as 1. So this way we can create a binary classification with the use of logistic regression. And this was the concept which we have discussed in our previous session. So here you can see that we are applying a all the values which are between 0 to 0.5 are considered as 0, and here we are considering it as 1. So this is logistic regression, and this is a case of regression where we are tweaking it to build a binary classifier. If you have any doubt in this, you can ask me any question.
Excuse me, sir.
Yes, please.
Sir, logistic regression को as a multi-class classifier कैसे use करेंगे?
Regression को as a multi-class classifier use करना थोड़ा सा tough है, but we can do it this way. Again, it is considered as a binary classifier. So let's suppose we have a classes like A, B, and C, and D. So first we will consider A as one class and all B, C, D as another class. So we will apply it for A by considering this, making it as a binary classifier. Then in second step, we will consider B with respect to all others. Then we will consider C with respect to all others. So this way हम इसको बार बार अप्लाई करेंगे, one for A, second time for B, third time for C, next time for D, and ultimately every time it built a binary classifier. But this way we can repeat it, and then we can check that whether what is the final predicted class, and the class which is giving us best probability will be considered as the winner. So this is the logic through which we can apply it in case of multi-class classifier. मान लीजिए 4 क्लासेस हैं A B C D, तो हम एक तरफ A को कर लेंगे और बाकी तरफ B C और D को कर लेंगे. So ultimately it become binary classifier. So we will train it. एक क्लासीफायर ये ट्रेन करेंगे. अगली बार नेक्स्ट हमें दोबारा से एक और क्लासीफायर ट्रेन करना पड़ेगा by considering B as one and A, C, D all three in another class. Third time we have to do this for A, B and D by considering this. So ये 4 बार हमें ट्रेन करना पड़ेगा और ultimately we can combine all these things to make a final multi-class classifier. But intuitively it is just a binary classifier. You got it?
Yes, sir. Thank you, sir.
So now we are here, please.
Sir, can probability be negative?
क्या?
Probability negative हो सकती है sir?
But no, because we are applying sigmoid function, and sigmoid function will be taking care about that. Probability always lie between 0 and 1 in this situation.
Sir. Okay, sir.
So we discussed another classifier called as K nearest neighbor. So here K is number of neighbors which we want to check, and on the basis of some kind of Euclidean distance, it identify the neighbors and check their class, and based on that it assign a new class to unknown member. So let's suppose I have two attribute x1 and x2, and these are my two classes. Here I have class 1 and this is class 2, and I have scattered all the data points based on the value of these two features, x1 and x2. So these are the data points which belong to class 1, and these are the data points which belong to class 2. And I want to predict the class of this new data point. So in this, the first step is to consider the neighbors of that particular data point. So let's first understand it visually. So first of all, we will choose the number of neighbors. So let's suppose I have number of neighbors as 5. So I will identify its neighbor on the basis of Euclidean distance. Euclidean distance formula is this. Let's suppose I have 2 points between P1 and P2. So I can find out the Euclidean distance through this way. So by calculating Euclidean distance between each of the data point, we can find out those data points which are nearest neighbor. So here we are considering 5 neighbors, and let's suppose these are the 5 neighbors. And then we will check the class of each neighbor and count it. So first of all, I have 5 neighbors, and then we will count the number of data points in each category. So you can see that in category 1, I have 3 neighbors. In category 2, I have 2 neighbors. So majority of my neighbors belong to class 1. So the final output will be class 1. So this is the basic logic of K nearest neighbor. Again, I am repeating. So here we have 2 data points. Here we have two attributes, x1 and x2, and on these attributes we scattered all the data points between 2 classes. Here this is the new data point. I want to check its class. So first of all, I have to choose number of neighbors. So let's suppose it is 5. On the basis of Euclidean distance, I can find my neighbors. So let's suppose these are the 5 neighbors. I will check their class. 3 belongs to class 1, 2 belongs to class 2. So I will go with the majority, and the predicted class will be 1. So this case is called as K nearest neighbor. So this is the logic of K nearest neighbor, which we have discussed in our previous sessions. So now, yeah, please.
Sir, if there are equal number of neighbors in both the categories, then what will be the decision?
Then it can go with any way, because there will be no effect in the output. So it will go with any of the members because both are equal. So it can go with any way. So let's discuss.
So how can we decide that how many neighbors we want to choose?
Yeah, so this is a case of performance tuning, and you can play with the number of neighbors. When you see the implementation of this code, you will see that we have to mention the number of neighbors. So if the number of you have to mention that number.
Okay, sir.
So then this way you can play with this.
So we can compare and go.
Yes.
Okay, sir.
Excuse me, sir. सर मैंने कहीं पे पढ़ा था कि अगर n नंबर ऑफ डाटा पॉइंट्स हैं तो उसका स्क्वायर रूट लेने से k की वैल्यू डिसाइड हो जाती है, तो ये ठीक है मेथड?
क्या दोबारा बोला?
कि अगर हमारे पास n डाटा पॉइंट्स हैं तो उसका स्क्वायर रूट लेकर हम फाइंड आउट कर सकते हैं कि k की वैल्यू क्या होगी.
हाँ कर सकते हो, मतलब these are the just guidelines ना, but ultimately you can play with that particular number, and you have to experiment over this, and yes, this is one of the guideline which you can apply.
Okay, sir.
So now we are going to discuss another classification tree and classification technique, and we are going to now discuss a decision tree classifier, which actually built a decision tree, and on this basis we can check the identified class of our classifier. So let give me. So I have already covered logistic regression. Now let's discuss a decision tree. So decision tree is just it got the name from the concept of tree. You can see that here I have a tree, but decision tree is considered as an inverted tree, where on the top we have a root and in the bottom we have branches and leaf. So एक तरह का उल्टा, this is just like a reverse tree, where on the top you will be getting a root, and in the then you getting branches and the leaves. So here you can see that we have a root, and then we have some branches and leaf, and on that basis we are making decision. So here I am giving you a idea about the decision tree by using the concept of whether a person should buy a phone or not. So here we are considering this on the basis of a cost. So we are comparing it as a decision node. So this is the root node. First of all, we will compare it on the basis of cost, and let's suppose if cost is more than 2500, we are not going to buy it. But if cost is less than this, then we will check its battery. If battery capacity is less than this, then we again don't buy it. But if capacity is more, then we will consider memory. Then after this we consider camera, and then if everything goes well, then only buy, otherwise we will don't buy it. So you can see that here we have lot of decision nodes. So all these points where we are comparing and we are making some path decision, all these are considered as decision node. And top node is considered as a root node. So here I have a root node, and then I have all these decision node. And in the end, where I am having my final decision as yes or no, all these are considered as leaf nodes. So you can see here, these are my decision nodes where I am making some kind of decision or using some kind of comparison. And then finally, I am having my leaf nodes like person is going to buy or not. So these are actually my classes. So these are classes which will be appear on leaf node, and all these are considered as decision nodes. So this decision tree is very important, and it is very useful in multiple situations. Let's suppose I have a data set where I want to predict whether the person will get a stroke or not. And I'm making decision tree on the basis of different attributes. So here you can see that on the basis of age, body mass index, and hypertension, I can predict that person will be getting stroke or not. And all these will be decision. How many decision node we have in this case? Can you tell me?
3.
And how many leaf nodes we have?
Sir, 4.
So yes, so on that basis we can make decision. For example, first of all, it will compare on the basis of age. Then if age is greater than 50, then it will compare body mass index. Then based on the current value of the body mass index, it will predict whether the person is going to have a stroke or not. So we can do this kind of model building with the use of decision tree, and ultimately it created tree and it split the data set, and then it makes some kind of predictions. So this is the intuition, and to further explain this intuition, let's consider one more example. So I have one more example to explain this. So let us consider this data set again, and we want to build decision tree to decide about the class. So here I have scattered all the data points between having two attribute x1 and x2, and all these are my scattered data point, and you can see based on the color I have two classes. Now I have to create if conditions on the basis of x1 and x2 so that I can create my decision tree. So what is the intuition behind that? So we have to split my data. So you can see first I can make split over here कि अगर इस वैल्यू से अगर x2 की वैल्यू इससे कम है तो ये सारे डेटा पॉइंट आ जाएंगे, अगर x2 की वैल्यू इससे ज्यादा है तो उसके ऊपर वाले डेटा पॉइंट आ जाएंगे. So this is the split one which I can make. Then still I will have no class. इसके नीचे भी दो क्लासेस हैं. अगर आप इसके नीचे चेक करें तो still I have two classes. This is one class, this is another class, और ऊपर भी दो classes हैं. So this is split one. और उसके बाद जो ऊपर वाला स्प्लिट मिलेगा उसके ऊपर मैं फिर एक और स्प्लिट करूंगा, स्प्लिट 2, और उसके बाद मुझे क्लास मिल जाएगी. तो ये पूरी जो है ये क्लास 1 है और ये पूरी क्लास दूसरी है. सो नाउ आई कैन फ्रेम माय इफ कंडीशन. पहले मैंने x2 को ब्रेक किया कि अगर x2 की वैल्यू ग्रेटर देन दिस है, और उसके बाद s1 को चेक किया कि मैं कह सकता हूं कि लेट्स सपोज दिस इज 50, लेट्स सपोज दिस इज 75. So can you frame this condition for this? So if value of x2 is greater than 50 and value of x1 is less than 75, then I will be getting class 1. So आप देख सकते हैं कि पहले मैंने ये if condition बनाऊंगा कि अगर इसकी वैल्यू 50 से above है और 75 से कम है तो ये है, और दूसरी कंडीशन हो जाएगी इफ द वैल्यू इज ग्रेटर देन 50 एंड x1 is more than 75, then the class will be x2. So here I am showing this particular case. So first this is split 1 and this is split 2, and for every split there will be some if conditions which will be created by the model so that it can classify the data set. So ऊपर वाला तो हमने classes find out कर ली, but still we have to again split it so that we can identify that particular data point in a different class. So for this we will do split 3 over this, and then we will do split 4. So ultimately by performing all these splits you can see that I can have my final classes, and for every split I will be getting some if conditions. For example, let's suppose this value is 60, so then I will be comparing it with 50, and on that basis I can frame my if condition. Let's suppose this is 70. So अगर इसके corresponding हम देखें, so first will be split on x2. So ये x2 आ गया, x2 is less than 60 and greater than 60. I will be comparing this. So if it is greater than 60, then we will be here, and then we will be comparing it with the x150 value. So here you can see that we are comparing with x150, and if it is greater than this, then it is class 1, otherwise it is class 2. So we have complete this split 1 and split 2, and after this split 1 and split 2 I am able to identify these two classes. But let's do this part now. If the value is less than 60, then we have to perform a break over here. So this particular break will be split 3 on 70, and this is on the basis of x1. So I will be comparing it with x1. So if x1 is less than 70, then this will be class 1. So here, but if it is more than 70, then again I have to make another split. So this split is on the basis of x2 20. So yeah, we are making this split, and ultimately we are getting this whole decision tree. So this step-by-step process will give you a decision tree. And again, as we have predicted whether the person is going to buy mobile or not, or whether the person is going to get stroke or not, the same way we can predict here that whether what will be the class based on the value of x1 and x2. So this is the intuition, and ultimately you can understand from this split that जो decision tree है जो भी आपका डेटा सेट है उसको हॉरिजॉन्टल और वर्टिकल लाइन में डिवाइड कर रहा है, बिकॉज इफ कंडीशंस आर क्रिएटेड ऑन द बेसिस ऑफ हॉरिजॉन्टल एंड वर्टिकल लाइन. So ultimately we are having some horizontal and vertical line, and on that basis it is building a decision tree. So this is important, a point of observation, that in order to build decision tree, the model is internally creating horizontal and vertical line, dividing the data set in horizontal and vertical line, and then it is building it. So again, I am repeating this concept. So we have this data set originally, and I want to divide this. So we have to perform multiple splits. So as I have mentioned, so first split will be on the basis of x2. So this is the if condition for that. But if the value is more than 60, then we have to break another case on 50. So if it is more than 60, then I am breaking it on the value of x150, and I am getting two classes for this. But if the value is less than 60, then we have to make a split on the basis of x170, and less than this we have one class. So you can see here, less than this we have one class, but if it is more than this we have to perform another split, and this way finally we are getting all our classes. So this is the intuition of decision tree, and final point to note is that decision tree is ultimately building some kind of horizontal and vertical lines. So let's go back and please.
Sir, if we instead of in decision tree, if instead of separate partition lines, we are having the mixture of samples that we can't draw certain lines, so then how decision tree works?
So of course, of course, some of the time it try to divide the points, but sometime it may not be possible. Let's suppose there is some data point here which belongs to other class, but it cannot split it. So in that particular situation, it will give you an error. So of course, it will not 100%. In this example, it has divided all the data set 100% accurately. But most of the situation, when you try to divide your data set between horizontal and vertical line, there will be some point here which belongs to another class. There will be some points here which belongs to another class. So all these will be true positive and true negative, and of course it will not be 100% accurate. Its accuracy will be quite low, and maybe 90% you can get in for some of the data set, but generally it is not that accurate, because you have identified it very correctly that most of the time data set may not be that cleanly split between horizontal and vertical line, and then you will be getting less accuracy, because then there will be a lot of true positive and false positive, that will be false positive and false negative, that will be reducing your accuracy.
Thank you.
So now let's go back and also start discussing the code, because we have discussed the three classifiers so far. So let's have discussion on code now. So here we are now, because in the last session we have implemented KNN and logistic regression. So I will be starting with decision tree, and we will be implementing other two also. But let's start our discussion from this data set. I hope you remember this data set. In this, we have to predict whether the person is going to purchase Alexa or not on that basis of these input attributes. Of course, user ID will not be important. You can consider these as input attribute and this as output attribute. But for the simplicity, I am only considering these two as input attribute and this is as output attribute, because I want to explain it visually. And in order to explain it visually, I can have 2D graph only. So I am considering only two dimensions. One is age and another is minutes of music. But if you consider gender, then it will be 3D graph, which is tough to generate and tough to analyze. So for making visualization simple, I am only considering two attribute, age and minutes of music. So you know that first of all, we have to load the desirable libraries. Then we have to load our data set, and in this case the data set is this. So we have loaded our data set by using read CSV function, and it is stored in this data set. And after getting this data set in a data frame, it will appear like this. And as I have already told you, I have to select age and minutes of music in X. So if I check their index value, it is 0, 1, 2, 3, and 4. So 2 and 3 should be considered under X, and 4th should be under Y. So here you can see in X, I am selecting 2 and 3, and in Y, I am selecting 4. So X and Y has been created. So if you have X and Y, X will appear like this, and Y is appear like this. So can you tell me what is the next step in this case? We have created. Anjay?
Train test split.
Train test split. Can we have to do one more operation in this case?
Feature scaling.
Yes. So we discussed that feature scaling is also important in this particular situation. So of course we are doing a train test split, but feature scaling is important because you can see here the age is of 2-digit and minutes of music are of 6-digit or 7-digit. So it's important to feature scale it. So there are two techniques for feature scaling. Can you remember that? What are those techniques?
Normalization and standardization.
So which one is best? Normalization kya karti hai?
The standardization is
Standardization.
How normalization works?
So in normalization, there is the problem of outliers.
So normalization is considered as min-max scaling, and it gives minimum value 0. Minimum value got a scale value 0, and maximum value got a scale value 1. So let's discuss this normalization. It is considered as min-max scaling. Minimum value 0 और maximum value 1 हो जाएगी और बाकी value उसके बीच में split कर दी जाएंगी, and this is the formula. And here we are using x max and x minimum to give updated value. So the problem of normalization is the outlier. So if you have outlier, then we normally follow standardization. So I discussed this in our previous example that if we have outlier, then the value will be skewed down towards 0 because I have a one outlier with very high value, and it will push all the value towards 0 because earlier when there is no outlier, 50 is getting 1 and 48 is getting 0.9. But if I have outlier, you can see here now I have an outlier with value 90. So this 90 will get 1 and 26 is getting 0. 50 earlier, which is getting 1, now it is getting 0.4. 48, which is getting 0.9, now it is just getting 0.3. So all the values just skewed towards 0. So in order to have this, solve this problem, we have something called as standardization. This just try to maintain a standard deviation 1 between different instances by using this formula. And this is the code for implementation of standardization. Here we have a class called as standard scaler, which is available in pre-processing. So we are creating its object, and then we are calling its fit transform method over training and testing data so that it can have data in scaled way. So after this, we have our data in a scalar form. In the same scale, you can see here my training and testing data has been scaled. So this is the pre-processing phase, and this is common for all the classifier, whether it is decision tree, KNN, or logistic regression. So now today we are going to build decision tree. So again, the code is for all the steps up to pre-processing, the code is same, and there is only a change of 3-4 line of code to change it for another classifier. So let's do this for decision tree. So as the name indicate, decision tree is available in a sub library called as tree, and this has a class called as decision tree classifier. So पहली बार हम एक नई class use कर रहे हैं decision tree classifier, which is available in tree sub library of sklearn, and in this we just have to specify two things. One is criteria to create decision tree. Actually, decision tree is created on the basis of concept of information gain or entropy. So this is the mathematical formula which it used to decide the split. I have shown you that we have to make split like this. So internally it requires some kind of mathematical way to decide कि पहले मुझे x1 पे split करना है या x2 पे split करना है. So that criteria is defined internally mathematically in this method called as entropy. And you know that random state is just a fixing of a seed value which give you that same behavior of the algorithm when you rerun your code. So
Excuse me, sir.
yeah, please.
So is there any other parameter for the criteria also?
Yeah, so there are two ways. One is entropy and another is Gini. So there are two ways to design decision tree. One is Gini index. This is based on the concept of Gini value. And another is entropy, which is based on the concept of information gain. तो आप इनमें से कोई भी दोनों में से वैल्यू स्पेसिफाई कर सकते हैं, but by default it is entropy. And you can specify Gini also. Gini is based on the concept of Gini index, and entropy is based on the concept of information gain. So we have created an object. So once object is created, what will be the next task? Yeah,
So
please.
fitting.
So yes, we have to fit it. So here we are fitting this. So I have mentioned here, if you have to use Gini, then you can specify it like this way. So next case is fit. So just here we are fitting this. So we are fitting it on X train and Y train. So model will be fitted. And then we have to make predictions. Predictions के लिए कौन सा method था? Dot predict. और predict में कौन सी value देनी है इसको?
X test, Y test.
X test या Y एक ही value आती है predict.
X test देंगे.
X test.
So predict में हम X text देंगे और ये X test है जिसपे questions होते हैं और X text देने के बाद मुझे Y predict मिलेगा. How I will be comparing its accuracy?
With Y
test.
So ये Y predict है, ये Y test है, and you can compare the results. So you आप देख सकते हैं कि यहाँ पे 7 दोनों में 1 है, predict में भी और test में भी. But there are some problems. जो decision tree है ये कह रहा है कि ये purchase करेगा ये records number 13, 15 और 16, but actually 0 है. So I have already told you कि उतना accurate नहीं होता decision tree, but still this is very simple and intuitive to make. And here we have these kind of errors. So how we can analyze our errors in a better way? What is the technique?
Confusion matrix.
Matrix.
To use confusion matrix. Very good. So we can use confusion matrix to design it. So here we have confusion matrix, and in this confusion matrix, you can call a method confusion matrix, which is available in matrix, and you have to pass actual and predicted values. So this will create confusion matrix like this. So let's spend some time over here. Can you tell me how many inaccurate instances we have?
So 9.
9.
9. Yeah. So we have 9 inaccurate. Can you find out true positive? True positive. कितने हैं?
62 upon
29.
True positive बोला मैंने. So of course these are actual. These are predicted. तो positive. तो positive पे 1 को देखना होता है आपको, 0 नहीं देखना. So don't confuse with this. 0 है. So this is true positive. What is false positive?
62.
3.
False positive. False positive.
3 sir, 3.
नहीं, अभी भी गलत है. देखो पहले मेरी बात सुनो, दोबारा सुनो. These are actual values. These are predicted values. जब भी predict होगा आप उसको, जब भी predict 1 होगा आप उसको positive मानोगे. So here we have a positive prediction and here we have a negative prediction. So ये n है और ये p है. अब actually भी 1 है और predicted भी 1 है, तो आपने उसको true positive बोला. यहाँ predicted 1 है but actually 0 है, so मैंने इसको false positive predict किया है. So यहाँ पे दोनों में जो prediction है वो n है, so n ऐसे लिख दो. अब actually भी 0 है, so it is true negative, but actually ये 1 था, so this is false negative. So this is the best way to decide it. जब आप ग्राफ देखेंगे तो 0 1 उल्टा भी हो सकता है, कई बार हम इसको ऐसे दिखाते हैं, तो तब आपको 1 को फोकस करना है. हमेशा predicted यहाँ होगा, actual यहाँ होगा, So try to focus on 1 and put P for 1 and 0 में आप n लगा दो और उसके बाद जब 1 1 दोनों है तो ये ट्रू हो गया, ये फॉल्स हो गया, ये 0 में ट्रू डाल दो, ये फॉल्स डाल दो. सो ये फंडा है. ओके, सो कैन यू टेल मी व्हाट इज प्रिसीजन इन दिस केस? प्रिसीजन कितनी है इस कंफ्यूजन मैट्रिक्स में?
29 upon 35.
35.
Yes, 29 by 35. कि जितनी बार आप पॉजिटिव कर रहे हैं, how many time it is accurate? So you are telling positive 29 time. Out of that, total 35 में से 29 time आप accurate हैं. Very good. And what is recall?
29 upon 32.
32.
29 by 32. So total 1 कितने ढूंढ पाए आप? तो actual total 32 थे, उसमें से 29 आप ढूंढ पाए. So ये recall था. And you can get this confusion matrix. Then we have calculations for precision and recall. We already discussed this, and this way you can find out all those cases. So then we can find its accuracy score, precision score, and recall score by calling corresponding method. We have method for accuracy score, method for precision score, and method for recall score. And we can also visualize this particular graph. So let's do this code in Python. So we have this. Let me import my library. So we have this dataset file, and on this dataset file I am working. So let's implement different classifier for this. So first of all, we are going to implement decision tree classifier. So I am importing all my libraries here. Then I am reading my file. So after this, I'm creating my X and Y. So this is variable explorer. So yes, we have this X and we have this Y. So let's do train test split. So we are performing train test split. So it has created X train, X test, Y train, and Y test. So if you check X train, the value are not scaled. So we will be doing feature scaling. So here you can see it has feature scale all the values. So someone has asked the question on YouTube that how we can do it if we have more than 2 attributes. So there is no problem in this. So we are just specifying full data set, and it is doing feature scaling over full data set. So if you have 3 column, it will do feature scaling on 3 column. If you have 4 column, it will do feature scaling on all the columns, because ultimately you are specifying your full training data, and it is doing feature scaling over full training data. So we have feature scaled data. So once we got it, we are building this classifier. So we are importing this from tree and building by using criterion as entropy. So decision tree has been built. Then we are making its predictions. So this is Y predict. You can see Y predict has been created, and this is my Y test, actual and predicted. For 7th row, it is correct, but you can see here for for 15, 13, I am predicting it 1, but actually for 13, 15, all are 0. So we are getting same results, which I have mentioned in my PPT. So we can build confusion matrix. So we are building confusion matrix. It is in CM variable. So you can check, this is the confusion matrix. And we can calculate all the values of precision, recall, and all those stuff. So this is my all the values of precision, recall. So you can see its accuracy is 91 and precision is 82 and 90%. So it is quite decent, but not that accurate. Now let's do visualization. So I have this method for visualization. Here I am passing my training values. So this plot is going to be interesting. So I want to show this plot. So here you can see that as I have already told you, it will give you horizontal and vertical lines. So अगर आप इसमें देखो तो ये क्या हो रहा है? So these are horizontal lines and there are some vertical lines. So you can see it is the same concept which we have just mentioned, and it has created various horizontal and vertical lines areas. And of course, in one of the area, if you consider this overall block, and you can find out that there are some data points which belongs to other class. So these are some errors in the training data. So because everything cannot be covered in this way, but it try to sometime overfit the data so that every data point can be covered by creating some kind of rectangle so that it can fit most of the data point accurately. So this is on training data, and same way we can do this for testing data. So you can see these are some wrong predictions made by our model, and this is what I want to show you, that yes, it is giving us horizontal and vertical breakup, which are important. So this is about decision tree. So
Excuse me,
let's
sir.
go back. Yeah, please.
So there are some functions which we are not familiar with in visualization. I have seen like mesh grid and all.
Yeah, it is quite complex. So just don't worry about that. You can anyway use the same code as such. So it is just for complexity. Here we are setting the mesh grid and all those points so that you can visualize it properly. But anyway, I suggest you to use this method as such whenever you want it, and just change the parameters which are interested. So this is a template which most of the people use as such directly. So I don't consider it is worth to spend time to understand how it is going, because otherwise it become very complex. Because it's more important to understand the working principle of those algorithms and to see how you can apply it and you can implement it. So this is about decision tree. So let's do one more classifier for this. We can apply k nearest neighbor. So here we have same data set, but there is only 2 lines of change in code. So here you can see to apply k nearest neighbor, we are using a class called as k nearest neighbor, which is available in neighbors. So decision tree is available in .tree. K nearest neighbor is available in .neighbors. So it is very intuitive to understand. And as you know, here we have to specify number of neighbors. So yeah, we are specifying number of neighbors as 5. Can anybody tell me what is the significance of these 2 points? Metric and p equal to 2. Euclidean. Yeah, so here we are specifying actually the distance which we are using. And how I can get itself, if you don't remember, anytime you can press Control I to get the corresponding help of that particular method. And this will show you the documentation which help you to decide the appropriate value. And here it is clearly written that in order to use Euclidean distance, you have to pass this and this. So you can get these values from documentation also. So here I am fitting it, and let's do it. Maybe we can do it. So here I am fitting this. Then we are making predictions. Then we are generating its confusion matrix. So this is the confusion matrix, and you can see that here the number of wrong instances are just 7. So this is better as compared to decision tree. So k nearest neighbor is giving us better results. Can you tell me what what will be the graph इसका कैसा होगा KNN का? So KNN plot,
Linear.
yeah, KNN plot will be non-linear. Very good.
There will be a slant.
And it is just like a map of a country. Yeah, you can see here it is non-linear. So जो भी non-linear होगा उसकी accuracy हमेशा better होगी normally. Or you can see that this is just like a map of a country, and that's why this is giving us little bit better results. So let's quickly also apply logistic regression, because you now know the theory also. So here logistic regression is available in linear model, and this is the name of the class. We are just creating its object by passing random state equal to 0. We are fitting the model, so only 3 lines of code is there. Everything is same. We are making Y predictions. We are getting confusion matrix. Let's check its confusion matrix. 8 3 11. So logistic regression is not giving good results. Why logistic regression is not giving good results? Can anybody tell me? Yes. Why it is not giving good result? Answer is here. Because here ये एक ही लाइन से सारा काम करने की कोशिश कर रहा है. डिसीजन ट्री ने तो फिर भी काफी सारी हॉरिजॉन्टल वर्टिकल लाइन बनाई टू कवर मोस्ट ऑफ द पॉइंट. अब इसके पास कुछ था ही नहीं, इसके पास सिर्फ एक ही लाइन है, तो इसने एक ही लाइन डिवाइड करना था क्लासेस को, बिकॉज इट इज अ लीनियर एंड इट ट्राई टू फिट ए स्ट्रेट लाइन. सो here it has only one straight line through which it has to classify all the points. But in decision tree you can see that you have lot more flexibility to create more horizontal and vertical lines, so you can cover your data points in a much better way in decision tree as compared to logistic regression. So that's why it has not as good quality as a decision tree. So decision tree se poor hai. And of course, it is not better as KNN because it is simple a linear model, and it actually जितने भी model हम करेंगे उसमें से मेरे ख्याल से सबसे poor accuracy इसकी आएगी as 11 incorrect instances you can see here. So we have see the demonstration of these 3 models. Let's go back now to check random forest. So random forest is also very simple and very powerful approach to create classifiers. So random forest. Can anybody tell me what is random forest?
It's collection of decision trees where each decision tree predicts something and majority is taken.
Yeah, so the random forest is considered as an ensemble learning. Ensemble learning means that we are ensembling or we are joining the decision of weak classifier to create a strong classifier. So यहाँ पे हमारे पास multiple classifiers होते हैं. And let's suppose we will be building classifier 1, classifier 2, classifier 3, classifier 4. And then we will be combining all these classifiers. और हर एक की हम वोट लेते हैं, और उसके बाद इनकी वोट लेने के बाद जो मेजॉरिटी का डिसीजन होता है वो हम फाइनली क्लास प्रिडिक्ट करते हैं. So instead of going only with classifier 1, we will be implementing all the classifier. और आप इसको ऐसे भी सोच सकते हो, आपने यहाँ डिसीजन ट्री लगा दिया, यहाँ पे आपने लॉजिस्टिक रिग्रेशन लगा दिया, यहाँ पे आपने KNN लगा दिया, यहाँ पे आपने SCM लगा दिया. तो हर एक से पूछ लिया कि आपको क्या लगता है, what is the predicted class. So everyone will say their own vote and you will go with the majority. If you can do this kind of stuff, it will automatically will give you best result. So we can do this kind of stuff by using concept called as ensemble learning, where we are combining multiple classifiers and then we are going with the majority, and that particular case is called as ensemble learning. So we are, by getting inspiration from this, random forest has been created. But in random forest, the difference is that instead of having different classifiers, we will be having all input classifier as decision tree. So we will be having decision tree classifier 1, decision tree classifier 2, decision tree classifier 3, decision tree classifier 4. We will be taking their vote and then we will go with the majority. And this is called as random forest because फॉरेस्ट मीन्स मल्टीपल ट्रीज, तो काफी सारे ट्री बना दिए. अब क्वेश्चन आता है हाउ वी विल बी क्रिएटिंग मल्टीपल ट्रीज. सो लेट्स सपोज यू हैव 1000 रिकॉर्ड्स. सो आई विल बी डिवाइड. तो मैं क्या करूंगा, रैंडमली आई हैव डिसाइडेड आई विल बी क्रिएटिंग 5 क्लासिफायर्स. तो मैं रैंडमली 200 रिकॉर्ड सिलेक्ट करूंगा और डिसीजन ट्री को बोलूंगा कि तुम इन 200 रिकॉर्ड को देख के डिसीजन ट्री बनाओ. So decision tree 1 is not seeing all the records. He is only seeing those 200 records and creating decision model with the use of those 200 records. अगले 200 रैंडम पिक करूंगा और डिसीजन ट्री 2 को दे दूंगा. अगले 200 रैंडम इसको दे दूंगा. सो हर एक को 200 रिकॉर्ड रैंडमली निकाल के दे दूंगा. एंड they will make their decision tree only by seeing those 200 records which I am supplying them. They will make their prediction and then finally I am going with the majority. So this is the intuition of using random forest, and in this case we will be combining multiple votes. So here in the beginning we have to decide how many decision tree I have to create. Then I will build those decision trees. So I will build decision tree for k data points. So at present, as I mentioned, I have 200 data points. So I will build decision tree by considering these data points. Then I will choose number of trees. So I will be repeating this, let's suppose 5 times, and this k is 200 in my case. So first of all, I will pick data points. Let's suppose I pick 200 and I decided to build 5 trees. So build the decision tree with k data points, choose n tree, number of trees, and then go back to step 1 and 2. So आप continuously ये करते जाएंगे steps, और you will be getting 5 different trees. Then जब भी कोई नया data point आएगा, you will take the output of all the trees and then you will go with the data points with the majority. So you will take opinion of all the trees and finally you go with the majority. So this case is called as random forest. Since this concept is inspired by ensemble learning, so that's why random forest is considered as ensembler. So this is the point. And random forest normally shows very good accuracy, and a lot of good classifiers or systems are built with random forest. One such example is this Microsoft Xbox, जो games आप play करते हैं. It uses classifiers to check the hand movements of the players. So internally, it used random forest classifier, and Microsoft recommended or built this random forest classifier for real-time post recognition for building Xbox. So this is their paper, and they used random forest in quite detail. So you can find out multiple applications where random forest is used, but the concept is very simple. First of all, you decide about data points, then you decide about number of trees. So you will be creating multiple trees by considering all those data points, and then finally you will be taking vote of these classifiers whenever you got a new data point. So this is intuition. If you have any doubt, you can ask me. So I'm going to now wind up my session with the code of this. So let's go back and quickly check the code of random forest.
Can a record repeat with many classifiers?
Pardon?
So can one record
we can repeat it with other, but the code will be different because here I am just creating classifiers as decision tree. But for building a normal ensembler, you have to use a different way, because first of all, you need to create all the classifiers and then you have to mix it. But here you can see random forest is simple A1 class. So here you can see that random forest classifier is available in Ensemble. So this is a class which I am importing from Ensemble, and these are the parameters which I am passing it. I hope that now you can understand why I am passing these parameters. So can anybody tell me what is the significance of these parameters which I am passing to random forest? An estimator, criterion, random state. Yeah.
I think we are making 10 decision trees here.
Yes. So Ashish Narang is asking about 1,000 record in each may possible. So actually here, जो मैं random forest की explanation कर रहा था, in CL1 is actually I am referring about classifier 1, not about class 1. So classifier 1 can give you any class output, maybe class 5, maybe class 7. Similarly, classifier 2 will give you one output, maybe class 3. Classifier 4 will give you another output, maybe class 1. So ultimately, every classifier will give you one output. And then you will be taking their majority कि किसने क्या बोला, कि कोई बोलेगा क्लास ए है, कोई बोलेगा क्लास बी है, कोई बोलेगा क्लास सी है. तो जो majority जिसकी तरफ जा रही होगी हम उसकी तरफ जाएंगे. And CL1 CL2 are actually refers to classifier, not at classes. So yeah, here we are specifying an estimator, that how many trees we have to make. Then we are specifying the criterion to build the tree. You know that entropy is one of the approach, other is Gini, and random state. So these are two for building the tree, and this is for building the forest. So tree ऐसे बनाएंगे, forest में इतने tree लगाएंगे. So फंडा बस simple सा है, बाकी fit और predict है. So let's predict this. Let's build confusion matrix and check its accuracy. So it is 9. So I think this is better as compared to decision tree, but it is not that accurate because here we have a very less data. Normally, if you have a huge data set, then random forest giving you good results, because here we already have very small data set और उसको भी हमने partition कर दिया, तो उतनी accuracy नहीं आएगी because already we have just how many record we have? We have just 300 records in training. So 300 record थे training के, तो 300 में से भी जब आप 10-10 के split कर दोगे तो 30 records मिलेंगे just एक decision tree बनाने के लिए. So that's why accuracy is not that good in our case. But if you have lakhs of record or more than that, then normally this will give you good accuracy. Okay, finally, can you tell me इसकी जो visualization है वो कैसे होगी? इसका plot कैसा नजर आएगा?
Non-linear.
So of course this is similar to tree. तो वो tree ही बनेंगे ultimately. तो it will be a mix of horizontal and vertical line, and it is little bit different from the final graph which we obtained for decision tree. But it's important it will be mix of horizontal and vertical lines. So this is all about this. So now we have two pending classifier. I thought I can cover SVM, but I'm not going to cover this in this session. So we will be discussing SVM and base in our next session. So my plan is for this course is that let's discuss it. So in next session, we will be covering support vector machine and name base. Then in next session, we will be discussing deep learning with artificial neural network. In that, we will be discussing different activation function, how deep neural network got trained. So forward, backward propagation, epochs, and all those concepts we will be discussing. And then in the end, I will be discussing clustering. And in that, I will be teaching you about K mean algorithm. तो अल्टीमेटली 3 सेशन मेरे ख्याल से हम लगाएंगे. अगले सेशन में हम करेंगे सपोर्ट वेक्टर मशीन और नेइव बेस, उसके अगले सेशन में आर्टिफिशियल न्यूरल नेटवर्क, और लास्ट सेशन में हम करेंगे क्लस्टरिंग. सो दिस गिव यू फेयर आइडिया अबाउट हाउ मशीन लर्निंग वर्क्स. ओके, सो लेट्स हैव क्विक क्विज.
एक क्वेश्चन था. Am I audible, sir?
Yeah, please.
Okay. सर जैसे अभी आपने बताया कि हम नॉर्मलाइजेशन और स्टैंडर्डाइजेशन लगाते हैं फॉर फीचर स्केलिंग. सर यहाँ पे तो हमारा सारा डेटा जो है न्यूमेरिक था, बट जो मैं काम कर रही हूँ सर फेक न्यूज डिटेक्शन पे, तो सर उसमें तो सारा डेटा स्ट्रिंग बेस है, तो हम उसको पहले कैसे एनालाइज करेंगे? मैं यहाँ स्टक हूँ.
Yeah, good question. So yes, this is very common problem that normally we have a string data set and how to handle it. So we will take one session more on text-based classifier. So I will cover as one of the session. I will cover it. Okay, don't worry about it.
Thank you, sir.
Sir.
So let's start this. So I have shared the link. Let's do this for YouTube user also. So YouTube user, please join this. We have 50 here, 70 here, total 120. Good. So I'm waiting for you. Please join, and I want everyone to join it. Just give me a minute. So let us start. Yes, it is logistic regression. Last question. So let's see who is the winner. So Angad is the winner. Angad, please unmute yourself and introduce to all of us.
Yes, sir. Good morning, sir. I am from Thorpe University, second year mechanical.
All right, good. That's good. God bless you. Saksham,
Good evening, sir.
good evening.
I'm a second year student at Thapa University, Computer Science and Engineering.
Good. Dishika. So everyone, Karthik, Rudrash, Aprajita, Chavan, Mayank, please. Yeah, Dikshika. Please unmute yourself and introduce to all of us. This is your time. Aprajita, Mayank.
Sir, good evening, sir. I'm a Prajita from third year, Thapa University, EIC branch.
Good. God bless you. Yes, next.
Sir, I am Uday Uppal from second year Thapar University.
Good. Yes. Anyone else? Yeah, please. This is your time. Mayank.
Hello.
Yeah. Yes.
Good evening, sir. Myself, Mayank Rawat. I'm from second year Thapar University, currently in CSE branch.
गुड. कोई थापर के बिना है अभी जो टॉप 10 में है? एनीवन फ्रॉम विदाउट थापर? Okay, we have everyone from Thapar. That's good. So let us do attendance. कितना सेशन है? 7th, I think.
7th, sir.
Yeah. So please don't share this link on Telegram because it will just so सिर्फ जो अभी अटेंड कर रहे हैं वही करें. It is approximately 120 students we have. So I am sharing the link. Yeah, please fill your attendance. तो अगले वीक इसी समय करना है क्लास? क्या कहते हो?
सर 7 o'clock रख लो सर.
7 बजे. आज हमने 7:30 शुरू की ना. चलो ठीक है, 7 बजे रखेंगे नेक्स्ट, because this is more convenient for me. So next week 7:30 था आज, अगली बार 7 कर लेंगे. चलो जी, थैंक यू जी, थैंक्स फॉर ज्वाइनिंग एंड आई विल आल्सो शेयर द रिकॉर्डिंग. ऑलरेडी अवेलेबल होगी ही वैसे. ओके, गॉड ब्लेस यू.
कोड भी शेयर कर देना सर उस पे टेलीग्राम पे सर.
कौन सा कोड?
सर ये क्लासिफायर्स का सर.
हाँ हाँ, वो मैं कर लूंगा. यस,
थैंक यू सर.
थैंक यू सर.
Excuse me, sir.
यस.
Sir, I have one doubt. In the last what we have done today, what is the need to split the data between the various classifiers? Like you have given the example, the 1,000 data points will be split into 200 and we will be giving them to the each classifier. But if all the classifiers are processing all the data points, like all the 1,000 data points are processed by all the classifiers.
Yeah, good point. नहीं, आपने अच्छा पकड़ा. So अगर तो हम ensemble में if I am using different classifier, like if I am using decision tree as one classifier, naive as another, SVM as third one, मतलब हर जगह अलग-अलग classifier है, then I will be giving the full data to all the classifiers. पूरा डेटा सबको दे दूंगा. लेकिन रैंडम फॉरेस्ट में क्या हो रहा था कि हियर आई एम ओनली यूजिंग डिसीजन ट्री. सो अगर मैं सबको सेम डेटा दूंगा तो एवरी ट्री विल गिव मी द सेम आउटपुट. So that's why I'm only giving them different records so that every tree try to find something different. So this is the reason that in this random forest I am giving different 200 record to each decision tree, because here we are building decision tree. And if I give same record to every tree, every record will produce the same decision tree. So there will be no variety in that. So in order to have variety, I am giving different record. But if you are different, if you are using different classifiers, like you are using random forest or support vector machine or KNN or decision tree, अलग-अलग classifier को ensemble करोगे, then there is no need to give different record. You can give them full record because anyway they are using different logic to build the classifier. So I hope I answered your question.
Yes, sir. Thank you, sir. Sir, one more doubt, sir. Like for feature scaling, how much like the data similarity should be there? The number should be in the same digit value, or like they should be on all in the hundreds or thousands value, or maybe there. How much difference is it like considered? And
yeah, so normally it is up to you as a database designer. You have to give a thought. जस्ट फॉर एग्जाम्पल मुझे उसकी एग्जाम्पल बहुत अच्छी लगती है ब्लड टेस्ट की. सो मान लो जब हम ब्लड टेस्ट कराते हैं, देयर आर सम वैल्यूज व्हिच आर इन लैक्स एंड देयर आर सम वैल्यूज व्हिच आर जस्ट इन 0.005 एंड इन दैट पर्टिकुलर सिचुएशन एवरी वैल्यू मैटर्स. तो जो 0.005 है वहां पे थोड़ा सा भी चेंज होने पे इट रेज एन अलार्म. सो in that particular case you can see that the range is quite wide. So whenever you find a different range, then you can always apply. And this is just a try that if after doing feature scaling accuracy improve, it's okay. Otherwise there is no harm in applying feature scaling as such. So if you feel that it can be helpful and there are different ranges and they are visible, then you can go for feature scaling.
thank you so much, sir. Thank you.
सर
Yeah.
सर अगर
Yes.
सर अगर न्यूमेरिकल वैल्यू में चेंज सर वो मैटर करता है, लेकिन सर उतना मैटर नहीं करना जितना हमारे सर बड़ा है सर, तो उसको हम रिड्यूस कर सकते हैं?
मैं समझा नहीं क्वेश्चन.
सर जैसे एज और म्यूजिक टाइम कंज्यूम्ड में सर डिफरेंस था सर, अगर हमें वो डिफरेंस मेंटेन रखना है, लेकिन वो जितना वैल्यूज में डिफरेंस है उतना एग्जैक्टली सेम ही रखना, थोड़ा कम करना है सर. सर मतलब
So then I got your point. Then we have something called as binning approaches होती हैं जिसमें हम उन values को scale करने की बजाय different bins में divide कर देते हैं. So then for example temperature है, so you want to keep the difference also, so then you can divide the temperature in medium, hot, mild and so on. So we can also do such kind of a strategy that is called as binning, और buckets बना लेते हैं डेटा की और उस वे से हम करते हैं. नॉर्मली आप एज में कर सकते हैं, यंग एज एज सच नंबर में स्टोर करने की बजाय यू कैन डू लाइक कि वो अडल्ट है, यंग है, चाइल्ड है, उस तरह से यू कैन प्ले विद दैट. सो बट अगर आप कुछ डिफरेंस मेंटेन करना चाहते हैं इस न्यूमेरिकली, तो वी ओनली हैव नॉर्मलाइजेशन एंड standardization, so that only give 0 1 and all those things. But there are some binning approaches or bucket approaches which can be useful in most of the cases जहां पे आप स्केल करने की बजाय उसको कैटेगराइज करना चाहते हैं.
यस सर. और सर वो जो एक्सप्लेनेबल एआई वाला है सर, वो सर मिस हो गया था, दोबारा जनरेट कर दोगे?
ठीक है, मैं वो चल नहीं रहा अभी.
सर मैंने देखा था उसके बाद तो सर नहीं चल रहा था.
Okay, I will send it.
Sir, hello sir. Sir, I have one क्वेश्चन सर, अगर आपने जैसे अलेक्सा वाला एग्जांपल लिया था तो उसमें हमारे पास न्यूमेरिक डेटा सेट था, बट इफ वी टेक अ कॉलम लाइक एज कॉलम इन विच वी हैव गिवन मेल एंड फीमेल, तो अगर हम उसको कंसीडर करते तो हम वो कॉलम के लिए जो स्ट्रिंग कॉलम था तो उसके लिए हमें कोई इनकोडिंग करनी पड़ती, लेबल इनकोडिंग और वन कोड इनकोडिंग?
ऑफ कोर्स हमें उसको प्रोसेस करने से पहले जेंडर कॉलम के ऊपर लेबल इनकोडिंग करनी पड़ती, 0 1 में कन्वर्ट करना पड़ता बिफोर बिल्डिंग द मॉडल। यस,
और अगर हम मतलब सिर्फ स्ट्रिंग डेटा ही लेते, स्ट्रिंग कॉलम से लेके, तो सबके लिए हमें फिर इनकोडिंग करनी पड़ती?
यस,
ओके,
सो प्ले करने पड़ती, मतलब स्ट्रिंग एज सच प्रोसेस ही नहीं होगा। सो आपको जो स्ट्रिंग है उसको यहाँ लेबल इन कोड या वन हॉट कोड करना ही पड़ेगा, उसको नंबर में लेके आना ही पड़ेगा अगर आप उसको करना चाहते हैं। सो देयर आर टू थिंग्स, एक है इस तरह का केस हो गया कैटेगोरिकल डेटा एंड लाइक दिस। एक होता है जो डेटा बिल्कुल ही टेक्सचुअल है, फॉर एग्जांपल जैसे अभी कोई बात कर रहा था कि हमारे पास आर्टिकल है जिसमें पूरा टेक्स्ट लिखा हुआ है और आप उसको चेक करना चाहते हो वो रियल है, ठीक है, तो वो यहाँ आपके पास एक कमेंट है और आप बताना चाहते हो पॉजिटिव है या नेगेटिव है, तो उस तरह से दैट केस इज कॉल्ड एज टेक्स्ट एनालिटिक्स। तो वहां पे वी हैव ए कंप्लीटली डिफरेंट अप्रोच। तो उस केस में आपको लेबल इनकोडिंग या ये वो नहीं करना पड़ता, वहां पे हम टेक्स्ट को एज ए मेंटेन करते हैं। बट अदरवाइज व्हेन यू हैव ए डेटा लाइक कैटेगोरिकल डेटा और numeric data, so you have to handle categorical data in any way.
Okay, got it, sir. Thank you, sir.
Yeah, any other question? So it is interesting to talk with you by sitting at Israel. Good. अभी कोई थापर में हो या कहाँ पे हो, घर हो?
सर हमारी अभी हॉस्टल नाइट चल रही है सर।
हॉस्टल नाइट सही है, दो हॉस्टल नाइट्स। हॉस्टल नाइट का समय आ गया, खत्म होने वाला होगा ये सेमेस्टर, फिर आप जा रहे हो।
yes,
किस हॉस्टल में रह रहे हो?
सर
वो नया हॉस्टल बना ना?
yes,
सर बढ़िया।